we start with the definition of Laplace transform. Definition. Let f of t be a function defined on interval from 0 to plus infinity. Then Laplace transform of function f, we're going to often call it f of s, equals to integral from 0 to plus infinity e to the negative st f of t dt, where the domain of L of f are all s for which the integral exists. That is the definition of Laplace transform of function f. Now we'll do a couple of examples on how we can find the Laplace transform of few functions. So we start with function f of t equals to 1. We want to find its Laplace transform. So we'll proceed from the definition. By definition, Laplace transform of f equals to integral from 0 to plus infinity e to a negative st times our function, our case function is 1, dt. We find antiderivative of e to a negative st, which is e to a negative st over negative s. And we do it from t equals to 0 to t equals to plus infinity. What we notice is we plug in upper bound, plug in lower bound, so we're going to get e to negative s times plus infinity over negative s. Minus minus give us plus, minus minus give us plus, e towards negative 0. Now what you notice is for this integral to exist, we wish that to be finite. So we wish that power on the top to be negative. To that to happen, we wish so s has to be positive. So if s is positive, we get negative infinity on top and e to the negative infinity is 0. So that equals to 1 over s when s bigger than 0. So to summarize, Laplace transform of 1, Laplace transform in 1 equals to 1 over s, assuming that s is bigger than 0. Our next example, we want to find Laplace transform of e to the at. So Laplace transform of e to at. So we write down corresponding definition of Laplace transform, integral from 0 to plus infinity e to the negative st e times function e to at dt. Then we're going to combine the powers of e. So we're going to get e to the t times a minus s dt, integral from 0 to plus infinity. We find the antiderivative of that function. So we're going to get e to the t times a minus s over a minus s. And we do that integral from 0 to plus infinity. So t is changing from 0 to plus infinity. Now to find this integral, we plug in infinity and 0 into an integral. So we're going to get e to the infinity times a minus s over a minus s minus e to a 0 over a minus s. We wish that to be finite. For that expression to be finite, we wish e to the raised to the negative infinity. For e to be raised to negative infinity, we want a minus s to be less than 0. If a minus s less than 0, when we have e to the negative infinity, e to the negative infinity is 0. So we're going to let this guy, so we're going to negative 1 over a minus s. It's more convenient to write down, distribute minus inside, so we're going to get 1 over s minus a. So to summarize, Laplace transform of e to the at equals 1 over s minus a, under assumption that s minus a is positive, or under assumption that s bigger